Hello. Hello. Am I audible? Hello, students.
Yes, sir.
Now? Yeah. Okay. Okay. So let me present. I'll start in few minutes, 1 or 2 minutes maybe. Just. The screen is visible, right?
No, sir. Screen not visual.
Oh. Is it now visible? Hopefully it is now.
Yes, sir.
And you can see it now, right? Week 3. Right. Should I wait for some more people to join or maybe 1 or 2 minutes maximum? Okay. Okay, good evening everyone and welcome to this tutorial of week 3 for the course named Calculus of One Variable. This is Rahuldev Ghorai. I will be teaching today. So, yeah, let's move to the summary of this today's topic. This week's topics are these are the things covered, right? So, derivative of a function, introduction there, like he described about algebraic rules of differentiation and of how derivative comes through the limiting thing, right? So derivative is nothing but a limit of the functions, you have the function difference over the difference over that small interval, uh, like you have this fx plus h minus fx over h, that limit h tends to 0, that is nothing but f dash x, right? So derivative is nothing but limit of this difference over the x plus h minus x, that difference. X plus h is nothing but x plus h minus x. And rule of differentiation, if you know this f and g are differentiable function, then f plus g and all these things, algebraic f times g, f over g, if g is not equal to 0, then all these things are also different. All those functions are also differentiable. And maximum minimum, To find maximum or minima, you first at maximum or minima x star, I think if that is the notation he used, that has to be equal to 0, and you have to know about f dash x, f double dash x naught, sorry, x star, that is greater than or less than 0 depending on the uh, minima, or we are finding minima or maximum, strict minima or maxima. And then you have Rolle's theorem, it's like f dash c, and the Lagrange mean value theorem, so that is fb minus fa over b minus a. When b and a fb is equal to fa, then f dash c has to be 0, and you have monotonic function and inverse of the function f inverse denoted by, right? So all these things are clear to you. I'm just giving a brief idea, like brief idea means briefly recalling many things are. So is this part is okay, right? This theory part, any doubt here, whatever he has done? So yeah, the way he taught, I think that's I think you all understand. If not, also you can ask me. Assuming all of you understood. Any, if you have any doubt, please speak instead of sending message. Maybe that will be better for me. Hmm? Is it okay? Yes or no? I can't hear you. If anyone speaking, okay. If even you are texting, so if you are speaking, you are like, yeah, then only I can understand. Okay, let me check the message maybe for now. Okay, anyway, so we'll be doing today some interesting questions. Okay, these are very useful. I feel. Hmm? So based on the things you have done, right? This is differentiability of x to the power 1 by 3. Let's start with differentiability of the function fx is equal to x to the power 1 over 3 in the domain x is greater than equal to 0, right? How to prove that function is differentiable at a point x naught or not, right? So what to do that? So this will be little easier, but you will see later this definition will be useful. Let's say okay, so start with, we are checking whether let x naught is uh, real number which is greater than equal to 0. For this moment, we start with x naught greater than 0. Then we need to find f dash x naught, or f is differentiable whether differentiable at x naught or not. Right? Why even taking x naught greater than equal to 0? Because that point has to be in the domain. Right? So when x is less than 0, its function is not given, not defined also. So what we take, we to see whether the function is differentiable or not, we need to find this ratio. And then we take limit as h tends to 0. If this exists, then we say it is differentiable, right? So f at x naught plus h, what will be this? X naught plus h to the power 1 by 3 minus x naught. So x naught over 1 by 3 over h. Now what to do here? Yes. What you will do here? How to evaluate this? Hmm? Let's come maybe right like this. Any guess here? Hmm? If c x not equal to 0, I can't hear you. If someone trying to speak, I can't hear you. If x not equal to 0, then this limit will be limit as h tends to 0, 0 plus h to the power 1 by 3, that is h to the power 1 by 3 minus 0 over h. That is equal to limit h tends to 0, h to the power minus 2 over 3, so does not exist. So most of the time I write dne, it's not dna, dne does not exist as to my notation, I can say. So when x not equal to 0, then that does not exist. Okay. But when x not equal to 0, so yeah, so does not exist mean f is not differentiable at x equal to 0 or x equal to x naught, which is 0, right? This is, you can understand. Is it okay?
Yes, sir.
Someone is telling x naught take outside. What do you mean by outside x naught? Yes, tell, please speak, no
I
problem.
wanted to use binomial expansion.
Sorry. Okay, binomial expansion. Okay, then you try with that, huh? But
Sir, it is
anyway,
fine, sir.
but x not equal to 0, that is ACAS, right? ACOA. So x not equal to 0, that case, we can see, try to do things by case, it will be okay. So x naught is not equal to 0, then this is x naught plus h to the power 1 by 3. What to do with this? Any idea? You have any idea other than this binomial expansion? I mean, only binomial expansion type of things, but much easier. So what happened to this ratio? You don't know now how to evaluate as h tends to 0. So this x naught plus h and x naught, they are also closer to each other as h tends to 0, and h is also tending to 0. So it's like 0 by 0 type of form is there. So you can't do just easily right here. What to do here?
Sir, use L'Hopital.
L'Hopital's rule.
No, well, much better. Here I am not taking any limit. Let's say first, can you make it much easier so that it will not be in a 0 by 0 form? Can you do that? See, something
Try
somehow.
to do something like a cube minus b cube.
Exactly, yeah, that is good. Who is telling that? Anyway, so that is the thing. So can you make it that x cube? This is a minus b. Think like that, a minus b over h, where a is equal to x naught plus h to the power 1 by 3, and b is equal to x naught to the power 1 by 3, right? Now if I make a cube minus b cube somehow, then it will be x naught plus h minus x naught, that will be h, and h and this h and other h will be cancelled. And what you see here, a minus b times a square plus ab plus b square, right? That is a cube minus b cube, right? Sorry, a square plus ab plus b square also, here you multiply, then it will be a cube minus b cube times h times a square plus ab plus b square, and that will be a cube minus b cube is h over h will get cancelled, right? I am not writing, so that's why it will be a square plus ab plus b square. A square will be x naught plus h to the, okay, let's write it below. Hmm? Okay, so let's write it below, and then it will be uh, 1 over x naught plus h to the power 2 over 3 plus x naught plus h to the power 1 by 3 x naught to the power 1 by 3 plus x naught to the power 2 over 3. See, now as h tends to 0, if you take limit as h tends to 0, limit as h tends to 0, this f of x naught plus h minus f of x naught over h, that is this quantity, this will be nothing but, like, if you have to take h tends to 0 here, h tends to 0 here will not make any problem, and you will get from here x naught to the power 2 over 3, from here also you will get x naught to the power 2 over 3, from here also x naught to the power 2 over 3. So what you will get, 1 over 3 times x naught to the power 2 by 3, and that is your answer. I mean, that is not equal to 0 also, that is finite number, right? That is x, because x naught is not equal to 0. So the function f is differentiable at x equal to x naught, where x naught is not equal to 0, means f is differentiable function for all x naught which is not equal to 0. At x not equal to 0, it is differentiable. So this is an example of a function which is differentiable at one point x not equal sorry not differentiable at x not equal to 0 and differentiable at all other points. So this part is understandable, right?
Yes.
Yes.
Good. Any so other people also please tell whether it is understandable or not, and then other once more I will discuss. Okay, so hopefully understandable. Okay, think it was easy maybe, but yeah, it was little interesting in the sense that this you have to make it a cube minus b cube so that it becomes much easier. No singularity things are there. So if you are done with this, then can you do this fx? So I'll just use different one. No, fx is equal to x mod x. Hmm? So whether like what are the points where it is differentiable? Hmm? F is the function. Is it defensible everywhere or some? What is the how to evaluate that?
So it is differentiable everywhere.
How you have done is calculation?
Yes,
No.
sir.
Why it will be at x equal to 0 also no problem.
Sorry, sir.
X equal to 0. See,
Yes, sir.
fx is nothing but x square when x is greater than 0. X is equal to 0, it is 0, so that is not a problem. X is equal to 0, it is 0, and when x is less than 0, this is minus of x square, right? Yes, am I correct, right?
Yes, sir.
And then the problem, if it comes, you have to realize that only problem might be if it comes at x equal to 0. Other points, it will not be problem. You can check it also. So fx is the function which, if the problem may come, that may come in x equal to 0. Otherwise, it is they are smooth. In the region x is greater than 0, x is less than 0, they are smooth. X square function, x square plus x square minus x square. So only problem may come at x equal to 0, but at x equal to 0, you can show that at h tends to 0, f of x plus h, which is x naught, let's say x naught plus h times x naught plus h mod. Okay, mod of x naught plus h minus x naught times mod of x naught over h, right? If you assume x naught is okay, x naught is 0 here, yeah, okay, so then it will be much easier, right? We are checking for x naught equal to 0, so limit h tends to 0, so h times mod h minus 0 over h, right? That is equal to limit h tends to 0 uh, modulus of h, that is h is greater than 0, h tends to 0 plus or 0 minus, that is always 0. So we have limit exists. So at x equal to 0 also it is differentiable. This function is differentiable everywhere. You can check it or all other points when x naught is not equal to 0. Differentiable everywhere. Okay, so I will write differentiability for differentiability this DIFF, the short notation. So please understand that. Okay, is it this one is okay? Hopefully this is okay, because first question I did that was much harder than this one.
Sir, if we replace f of x as x times modulus x to the power n, so
X time, sorry, fx is equal
x times mod of x to the power n,
to the power n. Yes,
whole power n, sir. Power
uh,
is outside the mod.
yes, write this like this.
So I am saying that this is differentiable if n is odd, even, and It is not differentiable at 0 if n is odd.
If n is odd, what you are telling, n is odd, okay,
Odd,
if
then this is not differentiable at 0.
not differentiable at 0. But n is when
If n
1,
is
then
even,
is
then it is differentiable everywhere.
n is even, then differentiable everywhere. Right? That's what you are telling.
Yes.
Yeah, that you can check it by doing for n is equal to, see, for n equal to 1, but it is differentiable everywhere, right?
Yes, sir.
So, but you are telling n is odd when it is n is not differentiable. N is odd, then f is not
Not sorry,
differentiable.
sir. If n is sorry odd, then this is not differentiable everywhere, and if n is even, not
Okay,
differentiable.
even n is even, then it is defensible everywhere. Sorry, uh,
Not differentiable at or 0.
at 0 only, right?
Yes, sir.
And it is n is odd, then everywhere defensible. Yeah, that you can check it. Once you put f x naught plus h and you check whether it is coming this problematic, because what you will get
But
at
for x is equal to 2, it is trivially differentiable.
x equal to 2, n
N
equal
is
to
equal
2.
to 2.
Yeah, n equal to 2, if you take, then it will be x times mod x to the power 2, right? Yeah, I mean it is
Which
defensible, right?
is
And then
x cube.
cube. No,
Because mod x square is x square only.
yes, yeah, that is x cube. This is x cube when whatever the value of uh, mod x square will be x square. That is, and x time that will be x cube. Yes,
So it is differentiable everywhere.
at x equal to n equal to uh, 2, right? Yes. So that is defensible everywhere, right?
Yes.
0 is not a problem. 0 will not be a problem, right? So that you can check by taking x naught plus h whole cube. No, that is will be h cube only, right? Yeah, h cube over h, that will be h square, that converts to 0 as h tends to 0. And yeah, you see 3x square is this derivative when n equal to 2. So I think it will be different way of telling this. Like something will be different maybe. Someone was telling, right? Is it given in the book that like exercise or something?
Sir, I have heard this.
Okay, you heard this.
For
That might be
May,
for mod x to the power.
maybe if x
Mod, yes.
maybe
mod x times x to the power n,
if
I
n
think.
is negative, then a problem could occur.
N is negative, yeah. Then my problem will be that n is even n is equal to -1. You take that will be x over mod x. I think that is even not continuous. So forget about differentiability, right? It's not even continuous. So this is 1 -1, and you have to define at x equal to 0. Maybe let's say 0 or something. X equal to 0, x is less than 0. Sorry, x is greater than 0 and x is less than 0, right? So this is we're not continuous. So not continuous means not differentiability, right? Not continuous. So imply not differentiability.
So
So that
can
is
we
different
generalize
question.
it, sir?
Sorry,
Can we generalize it, sir?
which one?
That that one, x times mod x to the power n.
Whether it is
Yes, the
differentiable or
for
not.
what values of n it is differentiable
Yeah, so that you have to
everywhere.
we have to check it, right? When see, he is giving, we are giving examples of n equal to 2 also it is defensible. Even n equal to 1, with n equal to 1 we did, right? This is x time mod x, that is also defensible. So yeah, you need much you have to do for some more n or something you have to do, then you can realize that. Yeah, for now I can't say what are the values of n. For that it will not be defensible, okay?
I think for even values it is differentiable everywhere, sir. Even values of n.
Exactly. Even values of n that you can say it is differentiable everywhere, right? Because that will be giving you that mod x will be x only. That square will be mod x to the power 4 will be x to the power 4, right?
Yes, sir.
Yeah. When n is even, it is differentiable everywhere. When n is odd, uh, at x equal to 0, you have to check. Otherwise, if it is x is not equal to 0, then it is defensible everywhere. I think it will be defensible for all n, it will be defensible. Okay. Yeah, that is the thing. You check it. For all n, it will be defensible because yeah, let's do it maybe. So x naught plus h, x naught is 0, right? In this case, mostly we will be checking for x naught equal to 0. So 0 plus h to the power means h times mod h to the power n, right, minus 0 over h, limit as h tends to 0. That will be limit as h tends to 0 mod h to the power n, that is equal to 0, right? Whatever n you take, that will be equal to 0. So independent of n, in or not independent, no, first of all n has to be greater than 0, let's say. Greater than 0, greater than equal to 0, that is okay. So n is when negative, then might be problem, so but that is not we are considering here. So even if you take negative n equal to minus 1, even minus half, that will be also problematic. Okay, so otherwise it will be defensible everywhere. Is it okay?
Yes, sir.
Yeah, because otherwise when is x is greater than 0, whatever this will be x time mod x to the power uh, n, that you can write as x to the power n plus 1, or x is less than 0, that will be x mod x to the power mod x to the power n, that will be negative of x to the power n plus 1. Whatever is that, they are polynomial kind of functions, and polynomials are defensible everywhere, like this type of polynomial, right?
Yes, sir.
Yeah. Yeah, I think I am okay, right? Is it okay, this thing?
Yes, sir.
Even if it's minus 1 to the power, if or n comes also, that will be no problem. So, yeah. Yeah, I mean, this is okay. So, this one minus 2 times, let's say minus 2 to the power 3. So, you will be getting plus. So, it depends on minus 1 to the power n, but that does not matter. Differentiability will be okay. So, this will be minus 1 to the power n times x to the power n plus 1. Okay, that you check it for different n. Okay, but whatever is that, that will be differentiable. So, what I space is differentiable everywhere for n greater than 0, or n is natural number. When n is natural number, that is n is less than 0, that will have problem. Okay.
Yes, sir.
Yeah, I hope it is clear. I think it is the x 0 x and 0. Okay, q and r minus q. Let's say that is also no problem. This was also same, but I'm writing this. Uh, how to approach this one? R minus q. Right. Find all the points where the function is differentiable. How to do this?
Sir, only at rational points.
Sorry?
Sir, only at rational points.
Only at rational points. Okay. Any other answer?
Only at 0.
Why? Any other? Any other?
If rational, the point is non-zero and it is rational, then it is not continuous even. So he is right that at zero it is differentiable.
No, 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 no. Other people tell. I will discuss. Okay. Someone who told x at x equal to 0 only. So can he tell why? The reason why only at x equal to 0?
Because
Yes.
if we consider the limit for rational points, it will be limit h tending to 0, h square minus 0 by h, which
Let's
is
let's
limit
write whatever
h
is
tending to 0 h.
wait. I will write. So that is x naught f of x naught plus h. You are mainly evaluating this quantity, right? If I am not wrong, right?
Yes.
Yeah. Then tell, please. Please go
If
ahead. Yes.
and that will be f of h minus f of 0 by h.
F of x minus f of 0 by x.
For 0, if we consider.
Okay. F of h minus f of 0 over h. True. When x naught is equal to 0, let's say, then this will be equal to this. Yes, true.
So f of 0 is equal to 0.
F of 0 is equal to 0. Yeah, that is true. So that will be f of h over h. Yeah, tell.
So depending on rationality of h, we can divide it into cases.
Yes, that will be h or 0 depending on if h belongs to rational number. Am I correct now? Otherwise, right?
Yes.
Otherwise.
Yes.
Yes,
And either way, as h goes to 0, both quantities go to 0.
that's true. Very true. So, f is differentiable. Very good answer. Differentiable at h equal to sorry x not equal to at 0 x equal to 0, right? The much
Yes.
difficult question is why not at other points it is 0. No, it is not differentiable, right? That is the difficult.
So again, we can divide it into
No,
cases.
you stay. And I'll ask you. You come little after some time. I'll ask you. But let other think that why at x equal to 0 people can understand it, right? Others you can understand why at x not equal to 0 or x equal to 0 y function is differentiable or not. For differentiability, you need to check the f of x naught plus h minus f of x naught over h as limit h tends to 0. Now we try to evaluate at x naught equal to 0, it is fh minus f0. And f0 means f is taking value 0. When it takes value 0, what it gives? 0 is a rational number. So it will give x square, means 0 square. That is 0. So fh over h. Now what is fh? Fh can be h square h over h will be then h, and if h is irrational number it will be 0. So whatever is there, that function is either h or 0, but when as h is very small, h is tending to 0, 0 will also converge to 0, h will also converge to 0, so this function will converge to 0, right, as h tends to 0. So this we have a limit. because limit exists and it is 0. So it is defensible at x equal to 0. Is it okay? Right. So yeah, hopefully you will understand. Otherwise, I can't say anything more. So, but what about x naught is not equal when x naught is not equal to 0? Yeah, tell now.
If x naught is rational,
Yeah, let's say x naught is not rational, or what you are telling.
it is rational.
X naught is rational. Let's say yes, true. Let's take
So f of x naught is equal to x naught square.
f of x naught is equal to x naught square. Yes,
It is positive,
positive.
but in a very whatever neighborhood we consider around x naught, there will be many irrational numbers.
True. Yes.
So all at those points, the value of function will be 0.
Yes. That is very correct concept. So you
So
have
I
to
guess
write
the
in.
limit won't exist.
Yes, mathematically you have to write. Yeah, that is yeah. But can you give specific maybe sequence? You know sequential criteria something? No. You know
No.
sequential criteria something. So sequential criteria says that if you have a limit L at x, let's say x naught x tends to x naught, you have limit f of x naught tends to L. The limiting says that this definition, if x n any sequence you know no uh,
Yes.
sequence you know, right? Sequence f of x naught is converging to 0, then f of x n that should also converge to L, and that has to that should happen for any x naught which is converging to x naught. These two definitions, limiting definitions, are same. This is sequential definition of limit. Any x naught you have which converges to x naught, which is at x tends to x naught, this is the point you want that limit. Any x naught you construct which converges to x naught, f of xn should converge to, for all those sequence, f of xn should converge to L. Then you can say that limit x tends to x naught, f of x naught is converging to L also. This is something little you, if you know, you can solve many questions. So that's why I'm just told this, which I think professor did not mention, but yeah, this will be used in solving many questions. You can just remember for it. This is very useful. You will see using this how rigorously we can prove that this at x naught is not, it is not differentiable. Even it is not continuous. First, it's not even continuous. You understand this limiting and this sequential criteria? This is called sequential criteria. Can you just
Yes.
yeah? So whatever you said, that only we will be using, but that is very precisely. So x naught is belongs to rational numbers, right? Now construct sequence of irrational numbers which converge to x naught. Can you give now any sequence, one sequence which converges into x naught? Sequence of irrational numbers. What is that? Xn. Can you give precise one? This is something like a good question, right? You have set of, and I told you, no, I do not tell, but
Sir,
yeah, you
x
have
naught plus root 2 by n.
exactly good square root 2 over n, right? This is a good example that x naught plus square root over n, which is a irrational number for all n, but as n tends to g infinity, it is giving you rational number x naught, right? So now the sequential criteria says that if limit exists, f of x naught should converge to, if it is continuous, that case it has to be f of x naught. Right? That is the limit. Up to this is okay.
Yes.
Now what is f of x n? Right?
0.
0.
It is converging to x naught square, which is converging to 0. Like whatever he says, that is only, but that's the thing. But it's much more precise, right? mathematically we are seeing. So this is not possible. This contradicts. It cannot happen. X not equal to 0 is we have already considered. If x not is not equal to 0 and x not is a rational number, then you can say 0 is sequence of 0 is converting to something which is greater than 0. That is not possible at all. 0 is a sequence which can converge to maximum 0. I mean only 0, right?
Yes, sir.
Right? Yeah. Okay, right?
Yes, sir.
Yes. Other Advait, I think. Okay, right?
Yes.
Yeah. Your name spelling is Advait, right? Am I wrong?
Advait.
Ad
Advait.
Advait. Okay. Now am I correct?
Non-duality.
Exactly clear.
Sorry.
Non-duality, sir. Concept of non-duality. So non-duality means Advait.
Okay. No. That I understand. That I know.
Yes,
Advait.
sir.
Yeah. Advait. Okay. Anyway, so this zero is this is understandable, right?
Sir, we can also
Yes.
prove this directly, sir.
Directly. How?
Sir, by the definition of the differentiability.
How?
Sir, by writing that ratio.
No. That's why I'm telling, right? It's not possible.
Sir,
Most
it
probably
is
it's not.
possible.
How?
Sir, it
You
is
tell.
possible.
Tell.
Yes,
Tell.
sir.
Let's do
Sir,
it.
if x naught is a rational,
Let's
so
say yeah, rational number, true, rational, and then it is like
sir,
this.
sir,
Yeah,
no, sir. So very first definition of differentiability is, sir, limit x tends to x naught, f of x minus f of x naught upon x minus x naught.
h minus h naught.
No, sir. Sir,
Yes.
sir, f of x minus f of x naught divided by x minus x naught, where limit x tends to x naught. So this is also the yes,
Understand. Wait. I am writing. I will write. Then you will say whether I am writing correct or not. Let's say it is x minus x naught, right? Yeah. Tell.
yes.
Right.
Uh, so sir, f of x naught is, sir, x naught square because x naught is rational. So f of x minus x naught square
Yes.
divided by x minus x naught.
Yes. Tell now.
So there will be two cases, sir.
Yes.
One will be, sir, x square minus x naught square divided by
X naught when belongs to, sorry, not x naught. That is the thing. X belongs to q. When x belongs to q complement or r minus q, that will be
the x naught square minus x naught square
over x minus x naught.
x
Yes.
naught. Yes, sir. So above upper limits, if x tends to x naught, it will be 2x naught, and if x in the second case, it will be, sir, infinity, sir, minus infinity. So
Exactly.
limit.
There, what you have to say. So at what you are taking, limit x tends to x naught, right? When you take x tends to x naught, x once has to be a rational number, another time it has to be rational numbers, right? It's not x tends to x naught plus and x tends to limit x tends to x naught minus. That is not you are taking. You are taking through x only when it is rational number, only when it is irrational number. When in that case it is coming this sequential thing is coming. You understand? So that thing when you what it is not taking limit x tends to plus x naught plus and x naught minus. You are taking x tends to x naught where x is a irrational number, x belongs to q. X tends to x naught where x belongs to q complement. So that too you can do it because that sequence exists which converges into x naught, which sequences are irrational. Yeah, I mean the concept is okay. I mean when you write this, but you have to when you write mathematically precise will be this sequential one. Here also you can say maybe you will write in language and all this thing will be okay, but I would suggest this sequential one more correct. But all of your concepts are okay. Concepts are like Advait also said that yeah, this neighborhood thing. So those things are only and whatever you are telling also the way is the concept is okay, but when you write you will understand also when you write you whatever you are saying here. If you write you will see the sequential one is much precise. You can just uh, uh, tell that yeah, it is contradiction, right? Yeah, I mean this way also. Okay, okay, right. I mean,
Sir, it is differentiable at irrational points.
sorry,
Sir, it is differentiable at irrational points.
not differentiable, right? Rational point, rational number.
I think, sir, it is.
What?
It is differentiable at irrational points.
Yes, that also. No, no, no. It won't be. It won't be. You can prove that because yeah, that is the thing. So if you use the sequential criteria, you will see you can construct sequence of rational numbers which converts to sequential irrational number. There is a construction in the many textbook you will find that is little hard, but you will mostly. I'll be writing here maybe. This you can in times x naught, which is greatest positive greatest integer function over n that will converge to x naught, where if you take x naught belongs to irrational number q complement. Okay, and this sequence, this you denote by xn. At this sequence, function is x square, right? F of x, f of this at xn, that will be x square. It will be giving you x square. But when you take the limit f of x naught, which is
Sir,
x,
is it a sequence of irrationals?
yeah, sequence of rational
Because
number
you are
which,
taking greatest integer, so it will give you a integer, na?
no, integer over another n is there, right? It will not be integer. It might not be integer, right? Above thing will be integer, but below also you have integer, so that will be again something like irrational number, sorry, rational number, right?
Yes, sir.
So rational number which is converging to irrational number.
Yes, sir.
Then f of xn will be this n x naught over n, that whole square, but this one will converge to, which will converge to, which should converge to f of x naught, but that f of x naught is 0. So what you will be saying then, n x naught, this square over n, that converges to 0, where x naught is not equal to 0, and you will see actually this sequence converges to x naught square, which converts to x0. So that again, that type of like contradiction you will be reaching.
Sir, I can prove this, sir, that this is differentiable at irrational point.
And defensible at irrational point, you can prove it.
Yes, sir. Maybe, sir, there may be some problem with my method, but
Let's do it. Maybe I will do it at the end. Maybe because place is not there. So let's do it here. Let's, you tell, or you want to do later.
no, no, sir, write it, sir.
Okay, you try it and then we will discuss. Okay.
Sir, I have tried, sir. You can discuss it.
Oh, you want to discuss it now? Let's do it then.
Yes, sir.
Yeah, tell. Let's do it.
Sir, using the
Yes.
definition of differentiability
Huh?
like above.
Right?
Yes, sir.
Yes.
We will having two cases.
X naught belongs to Q complement, right?
Yes, sir.
So when X naught belongs to Q complement,
So f
if
of
you,
x naught is 0.
okay, so that is f of x over x minus x naught you will be getting.
Yes, sir.
That is equal to,
X square upon x minus x naught when x belongs to rationals, and 0 when x is irrational. So the above limit is first limit is, sir, also 0
how? You are
because
taking x tends
yes,
to x naught,
where x naught is non-zero.
where x naught is non-zero, yes?
Yes. So you can take x common in the denominator. So x and x will be cancelled out.
Sorry, how? What? You have
Okay, sir. Got it, sir. Got it.
yeah.
Ah,
Mostly it
I was,
can't. It should not be. It should not be.
yeah, it will not be zero.
Yeah, it will not be 0. Yeah, by that also you can say. But the yeah, that's how you take. You tell that sequence of irrational number which converts to this x square over x, no x not rational, but a sequence of rational number which converts to 0. So that also, yeah. Mainly this precise
Sir, in
precise.
case one, I was treating x naught as zero. That's why I got the limit zero.
No, 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 x not 0. Then it is defensible. We have
Yeah,
already
yes,
proved
sir.
that.
Yes, sir. Got
Advait,
it.
Advait, it is okay, right? This sequence with this sequence.
Yes, yes,
You understand, right? Like that other one you can
yes, yes,
consider. Yeah. Okay. Uh, and Sandeep also you now understand, right? It's only difference
Yes,
of that
sir.
is
Yes,
equal to
sir. I
0.
got it.
Okay.
Thank you, sir.
Okay. Okay. Now let's do this one. This will be easy. So I don't want to do just you do it. I will just check it maybe. You want to otherwise you can leave it also. You can do some other program. This is easy, right, for you people?
yes,
Yeah, maybe quickly I will do because maybe I will be uploading this video. People will be checking. So for them, let's do it because let's assume that f is differentiable at x equal to 2, and then we'll find value. So if it's differentiable at x equal to 2 means it is continuous also at x equal to 2. So limit as x tends to 2 plus fx should be equal to f of 2. Also it will be equal to limit of x tends to 2 minus f of x. What is x tends to 2 plus, that is 2a plus b, right? 2a plus b, that is equal to f2, which is 2 square, is equal to as x equal to minus 2 minus,
Sir, age 4b is minus 6.
sorry.
The age 4b is minus 6.
Okay, so that is one relation we'll be getting. And then limit as x tends to sorry 2 plus x 2 plus x will be let's say limit x tends to 2, right? No, let's do it by h tends to 0. That is much easier for me. 2 plus h will be a times 2 plus h plus b minus f of 2, which is 4 over h, right? That is equal to limit as h tends to 0. I'm making some mistake here, something wrong. No, limit as h tends to 0, it will be uh, a h plus 2a plus b minus 4 over h. That will be equal to a plus limit h tends to 0 2a plus b minus 4 over h. But 2a plus b is equal to 4. So you have that limit is also 0. That is equal to a, right? Am I doing something wrong? No. A. So it is differentiable for all the a b such that 2a plus b is equal to 4? No, right?
Sir, we can directly differentiate two parts and then evaluate at 2. Like 2x is equal to a, where x is equal to 2.
But I did not say it has to be continuously differentiable, right? Why do that?
But the derivatives must be equal, na, sir, from two parts.
No, why?
Is it not correct?
It need not, right? They need not
Sir,
be
if
differentiable function. That might be discontinuous. You have no problem with that. I think some problem with this question where it has to be continuous. If it is asking the derivative is continuously differentiable, in that case you can find a and b. Otherwise, I think with any 2a plus b is equal to 4, any a b you take such that 2a plus b is equal to 4, it will be differentiable most probably. I'll check the answer and maybe I'll tell, but most probably this will be the answer.
I mean, we can take the left hand derivative and right hand derivative.
Yes. Is it coming different? Is it coming different?
No, we can equate them.
No, no, that is because you can see from here,
But
right? What else it can be? Because it is coming A itself. It is not giving for h greater than 0, less than 0. It is different. It is not coming, right? It is even h tends to 0 I'm taking. Any h tends to 0, it is coming A.
no, but if you take h tends to 0 plus,
Yes.
then I think this definition is valid.
No.
But
Because
for
A
0 minus, a different definition is valid because the function is split up 2.
function is
Split
good,
at
good,
2,
good,
right?
good, good question. Good observability. Exactly. This is 0 plus. Okay. Yeah, that is the mistake we are doing, because 2 plus h is greater than 2 in that case, right? 2 plus h is greater than 0, h is greater than 0, and 2 plus h good otherwise. So yeah, h is less than 0, right? So that's why when if you take limit extends to 0 minus, this definition will change. F of 2 plus h, that will be then 2 plus h whole square, right? 2 plus h whole square minus 4 over h, right? Correct? Because f2 is 2, so that is not a problem, and h tends to,
Yes.
yes, and then it will be limit h tends to 0 plus, yeah, that was a mistake. So that is then 4 will get 4 plus 4h plus h square minus 4 over h. So that limit will be 4 cancel, only 4. So a will be 4, yeah. So a will be then 4, and we have a plus b is equal to.
So that is the same approach I have used, sir.
Good, good. Okay, okay. Yeah, yeah. I thought I made mistake. Yeah, that is correct. If you have meant this is the answer you got, right? A is equal to 4, b is equal to minus 4, right?
Yes, sir.
Yeah,
Yes.
that is correct. Yeah, thank you. I did not realize this. The definition will change. So yeah, with this definition, because in the definition itself, I have used that h is greater than 0. In that case, only 2 plus h will be greater than 2. Otherwise, it will be less than 2. Okay. Yeah. See, I thought it is easy, but it troubled me like anything. Okay, and this one will be also similarly, right? So how we do that for differentiability? Fx equal to x to the power r. So this type of question may come in the use. I've seen in the NET exam or JAM exam like that. So it may come. So this is, I mean, it used to come. Now I don't know whether it will come. But x to the power r sine of 1 by x. Okay. So if you have this, and if you take limit as h tends to 0, sorry, x tends to 0, f of x, that will be x to the power, limit x tends to 0, x to the power r sine of 1 by x, and this function is bounded function, and this function tends to 0 only when r is greater than 0, right? Just greater than 0, not even equal to 0, right? If you take x is equal, r is equal to 0, r is equal to 0, then it will be sine of 1 by x, which does not converge to 0, I mean, as x tends to 0. So why I did this? So this is limit as x tends to 0, f of x in this case is coming 0, which is equal to f of 0 as they defined only when r is greater than 0. So when r is greater than 0, then only the function is continuous. So that is what also given in the question. So that's not a problem. R has to be greater than 0. Now for differentiability, what you need. So can you tell me do I need to check when x is not equal to 0 the function's differentiability? Do I need to check that when x is not equal to 0?
Yes.
Do I need to check that? No, right? Because
Yes,
when
sir.
x is not equal to 0,
No, no. For zero, you
right?
have to check.
Because at those points when x is not equal to 0, these two functions are differentiable function, right? Sine 1 by x,
Yes, yes.
right? Sine 1 by x and x to the power r, when r is greater than 0, they both are differentiable function. When you don't have any 0 in the domain, x is not equal to 0, they are differentiable. So if you take the product, they will be also differentiable. So other than 0, you don't have any problem at all, right? But problem arises when x is equal to 0, means at x equal to 0, right? So we will be
I mean,
that's
for negative values of x, you can have problem.
sorry, why?
For negative values of x, we could have a problem because
R, if r is
x to the r could be undefined. For example, if r is an
if r
irrational
is
number.
equal to half and all, okay, okay, so that, yeah, so that's why you have to take yeah, bigger r. I mean r is in that case greater than, wait, what I wanted to say, okay, this x to the power r has to then be defined. So x is less than 0, only if it is defined then done. But yeah, but when x is less than 0, so your r has to be then natural numbers, otherwise you cannot yeah, I mean yeah, so that case it is not defined. So x is when uh, for all the other values, so when is x is less than 0, let's say x is less than 0, r has to be your like 1 2 3 like that, so natural numbers mainly will be concerning. That's why only greater than equal to 0. But when greater than equal to 0, when x is greater than 0, then we have uh, x is when strictly greater than 0, that is defensible everywhere, right?
Sir,
uh,
you are talking about R or X?
sorry, in x is greater than 0, defensible for,
Sir, if R is greater than 0, then the function
yes,
is.
yes, when r is greater than 0, for all r greater than 0 it will be defensible if x is greater than 0 at x equal to c. For all, I'll write this, for all x is equal to x naught, which where x naught is greater than 0, this function is differentiable. F is differentiable for all r greater than 0, because this function has a r, right? This r is greater than 0. But when x is, sorry, x not x, x naught is less than 0, it is even not defined. So to make sure it is defined, then it has to be r equal to like this, uh, or 0 also it can be, so but it's strictly greater than 0 is taken, so only then it will be differentiable. But now come to the question where they only ask about for which r function will be differentiable at 0. So you don't need to now bother about all other points, because you are asking about all values of r for which the function will be differentiable at 0 only. Hmm? So you don't need to bother about x equal to x naught. X naught is greater than 0 or less than 0. X naught is equal to 0 for our case. Now we take the ratio, which is over h, and that will be then uh, okay, h to the power r sine of 1 over h over h, right? Because f0 is 0 given, so h to the power r minus 1 sine of 1 over h, So now limit as h tends to 0, h to the power r minus 1 sine of 1 over h. Whether this exists or not, that question comes. Right?
For r greater than 1, it would exist.
R just strictly greater than 1 or equal to 1?
Be greater than 1.
Just strictly greater than 1, right? So
Yes.
this limit will be is equal, will exist and equal to 0 if r is greater than 1. You can check with r equal to 1, that will not be true, and other things also if you take, it will not be, uh, it will not exist.
So for
Because,
But the
continuity,
left hand derivative does not exist.
sorry,
The left hand derivative does not exist.
for what?
For this function, because when h is negative,
Yes, that
then this
again,
function
that,
won't be defined.
okay, so that the, yeah, that way also you can say yes, yeah, that is true. H is less than 0, then this r, even that will not be thing. But other than that, you can
So if
r
we
is,
restrict r to integers, then I mean positive integers, then
but you
it is
you don't
different.
have any integer between 0 to 1, right? So you don't have that thing, right?
Yes,
You are
but
talking about,
even for r greater than 1,
yes,
for like for a value like square root of 2,
r is let's say r is equal to, okay, yeah, that is also problem, right? But that should not be the thing. If it's determine the values of r for which it is differentiable. Wait. Is the domain. Domain is not also 0 to 1. Okay. It's not coming for all value of r which is greater than 1, right? Because 1 plus half, let's say r is equal to 1 plus half, then it will be h to the power half sine of 1 over h.
sir, it is a bounded function sine 1 by h, and h to the power 1 by h, 2 is a null sequence, so it will be a null sequence eventually.
No, but his concern is, it is if h is negative, let's say h is less than 0. How do you define this thing? H to the power half. It's not even real number, right? It will be imaginary number. His concern is imaginary. Hmm? That is the concern.
but if we don't care about left hand derivatives, then no problem.
No, but you have to here care about that, because that thing is there, right? This h tends to 0 or plus minus both is there. Is it did a mistake or something? We think, let's think about for some time. I will do that thing. What is the mistake we are doing? Any mistake? Like, I am expecting that any r greater than 1 it should work, but and from my experience, but uh, here I stuck that it's not the thing. Hmm?
Sir,
You
h
can
is
try for
always,
r is equal to square root
sir,
of 2.
sir,
Yes, tell.
sir, h is always taken to be positive, sir. Why are you considering h as negative?
No, it can be also negative, right?
I mean, for
Why,
r is
why,
equal to
sir,
square root of 2, it doesn't work.
when we define left hand derivative and right hand derivative, then we take h as a positive.
No, never. Because it's converts to 0. So that in that case, you do that this definition, the different definition, f of x naught means f0 minus f of 0 minus h over h. That case limit h tends to 0, that h is positive. It's not here the definition I use. Here I use f of 0 plus h minus f of 0 over h. So in this case you have to take h tends to 0 plus and h tends to 0 minus. Okay, check your definition. It's not true. Think about something else maybe. How why is the thing? See, it might be the case that it has to be the all the natural number always. The r is natural number, but I feel it is not. Yeah, I don't find a mistake here. Most probably R will be natural numbers. Okay, have these given values of R for which x to the power R sin x. And its problem is even in defining the function when x is less than 0. Hmm? If f was the function which is from uh, r plus mean x greater than 0, then you would not have any problem. But that is not the case. Here is f is the function from r to r, right? So that is where the problem. And that's why when x is less than 0, even this function, the given function uh, will not be defined, right? Yes. So that is the mistake we are doing here.
Yes.
You understand? I think the question has to be different. Question has to be x is greater than 0. Hmm?
So,
So
sir, basically you want to say that the limit of the function x to the power 1 by 2 sin 1 by x when x tends to 0 does not exist.
exactly, if you take whole real number, if you take whole real number, that should not, because it is not even defined. How do you talk about this limit? Hmm?
Hmm.
If I am not wrong, this will be the thing. Like if I'm not overlooking at things, even the function is not defined. So this function this question I took from somewhere, but might be mistake there. So you assume it is greater. It is. See, if it is not, then you have to take the only natural numbers. R is natural numbers, right? Natural numbers which is greater than one means it is 2, 3, 4, 5 like that. Otherwise, though, you have to restrict the function at f is from f r plus to r. Then things will be much beautiful. Means r has to be r will be any real numbers which are greater than one, right? So, okay. So this if if you want to keep this as the function, then even for at x equal to 0, the function will not be defined. So to take f from r plus to r and then do all the business here. So this part will now don't need, and x not equal to 0. So when if only you take h tends to 0 plus, you will be taking here, and then it will be 0, right? Then r is greater than 1, any real number, it will be uh, valid. So the function will be differentiable at x equal to 0 for any r which is greater than 1, any real number it can be, right? So please,
But if we restrict the domain to R plus,
yes, yes.
0 is not in R plus. So how can we talk about
R plus
differentiability at
union
that
0,
point?
sorry, R plus union 0, yes, sorry, R plus I just assumed R plus is union 0 is there, so R plus union 0, or you can say uh, from 0 infinitive to R, okay, if you have that thing, yeah, sorry for that. So it has to be R plus union 0. Now okay, right?
Yes.
Yeah. R plus equal n zero, yes. N zero has to be there, otherwise how do you do that?
Sir, in Google it is given for all r greater than 1. It is differentiable, sir.
Defensible on which domain?
Sir, r greater than 1 and r to r.
R greater than 1, R to R.
Yes, sir.
I mean, how it is possible? Even I thought that it will be, but how it is possible? Hmm? It's not possible, right? It's not defined. How do you make sure that it is converging to zero? They may do something. I may say that it's h is less than zero, right? So you take h less than zero, but uh, square root of h, then it will be uh, I times square root of minus h. Sorry, what I'm doing. H square root of h, right? So that will be negative minus 1 times minus h. So that will be I times square root of minus h. Now this converts to 0. That is always that converts to 0. But it is complex numbers. It is coming that type of. So in that sense, you cannot take here because it's a real numbers we were doing, right? Right? Square root of h that converts to 0. I times square root of h also converts to 0, right? Because that is 0 times I. And minus h is not defined because h is less than 0, but to square root of minus h. But this should not be like this way. I mean, a complex number should not come. I don't understand why it is. They can say that. How they can say that? Some mistake will be there. That is for sure.
Yes, sir.
You understand? So, in the Google, wherever or Google or whoever says, they have to then come through this one. That h is less than 0, then how h to the power half converts to still can converts to 0? H is less than 0 and h is converging to 0. Then can you say
Sir,
that h?
it is on the sir mathematical stack exchange website.
Yeah, exactly. So if they say they are overlooking these things, right? Each h to the power half, that is not a sequence of real numbers. It's not in the real numbers set. Still, it is. I mean, it's not defined in that sense. Then if it is not defined, so it is still converging to 0. So that sense, if they take, then it will be okay. Otherwise, it is not okay. It's not defined in real number. And you don't know about this complex number things.
Yes, sir. Okay.
Uh, so I think better for now.
So non-negative, if you consider non-negative real, then we
Exactly,
can.
exactly. Then we don't have any problem.
Yes,
Hmm?
sir.
Still, I'll look at it, but hopefully this is the thing. Hmm? People may overlook things. This because this was I thought this is the standard example people consider, but here what you see here x is less than 0. You have issue, and you are telling also in the internet it is given. So might some people might do it by overlooking, or we are doing something mistake. If we are doing that, I will tell you in the next class, okay, about this question 3. Okay, sorry for this, but yeah, otherwise you take this as x is greater than 0, then you have r is greater than 1. For r greater than 1, it is differentiable. And for the continuously differentiability, for this one, you do f dash x and you check the continuity of the function f dash x. So f dash x will be, if it's at x is as x is differentiable, f dash x will be like x to the power r minus 2 cos of 1 by x plus r times sine of sine x to the power r minus 1 sine of 1 by x and 0. So now you take limit as x tends to 0, whether f dash x and f dash x is converging to 0 for what values of r. So you will see r has to be greater than 2 again. So r has to be strictly greater than 2, any real number, if you want to consider r plus f is from r plus union 0, then it has to be r is strictly greater than 2. For that,
So
f is,
there is negative sign in the first term.
sorry,
There is negative term sign in first term.
negative will be coming. Sorry, negative will be coming. Yes, whatever the derivative that, yeah. But yeah, r it has to be greater than 2, strictly greater than 2, right? Uh, yeah, and I will think about it. Most probably, it will not be the if we are considering from R to R, is that valid one? Should not be valid because
Yes, sir.
problematic at, you can understand, right? Square root of a, it will converge to 0, but it's not in real
Sir,
numbers.
most of the time they do not mention about the domain, sir.
Yeah, either
Yeah.
they will not discuss about the domain, or I have seen many places that they take this 0 to minus, I mean from
Yes, sir. Yes,
0
sir.
to infinity,
Yes,
not
sir.
minus 0. I have seen places, but
Yes, sir. But most of the time they do not mention about domain.
did not mention, right?
Yes, sir.
Okay. Yeah, I'll see anyway about this. Okay, is it okay? Both of you?
Yes, sir.
We are learning few things, right? I mean, this question was some confusion, but otherwise we are learning, right? Or not? Or you need some more difficult question?
Yes.
What about question 4? You want to try? Or I'll do? Because time is also going. Let's do a try for 3 minutes, maybe maximum. 2 minutes. It is very easy.
Done, sir.
Sorry?
Done.
Solved.
Yes.
Very good. So, what you did? Okay, okay. Let's wait. Let's Sandeep do whether he is doing. Trying Sandeep.
Yes, sir. I was trying to use the Lagrange mean value theorem.
Yeah, I mean that is the thing you have to use. Construct in such a way that this thing become. Yeah, I mean I don't know how to say that. I mean this if dash t is equal to 2t, you usually don't get, right? Some constant you get usually, right?
Yes, sir.
So that's why you have to make something like so that 2t minus 2t is equal to 0. That is a hint now you do.
Sir, uh, hmm, f of
Some
1 by 2, sir, f of 1 by 2 is equal to f dash 1 by 2 is equal to 1 into 2 into 1 by 2.
no. What you are telling? F of
Sir, f of 1 by
2 is equal to
2 times 1 by 2. which
2
is
times
1.
1, which is 1. So what? I mean, do
So
you know?
using Lagrange mean value theorem, so, uh, we must have some point where derivative is 1, f of 1. So f of 1 is equal to 1.
F of 1 equal to 1, yes. So you understand what you are making mistake. I mean, what you are telling is nothing coming, right?
Yes, sir.
Yeah. So that's why I think Advaita also did like this. I'll tell him and I'll ask him after that. See what I told you. F dash t minus 2t is equal to 0. You have to come at some point. So then you are not understanding. So that will be nothing but f of t minus t square. That derivative has to be equal to 0, right? At some point. I mean, that is, let's say fx minus x square. That derivative of that at x equal to t will be 0. So there has to be some point for that x, for that point the derivative is 0. So that is Rolle's theorem, right? That usually comes from Rolle's theorem, is not it? Gx is equal to, let's say, fx minus x square, and let's see g of 1. What is that? F of 1 minus 1, which is 1 minus 1 is 0. G of 0, f of 0 minus 0 is 0. Can you use now Rolle's theorem? Fx is differentiable function, x square is differentiable function, g will be differentiable function, because and g of 0 is equal to g of 1, so g dash c will be, or g dash t, some t will be equal to 0. And what is g dash t? That is nothing but f dash t minus 2t is equal to 0, and that implies f dash t is equal to 2t. There exists a point t. Understand? And you understand how it is coming? Things are like, you come trace back and you get it, the function. Hmm? Understand? Advait you do it like, did like this?
Yes, yes, same method.
Okay. And Sandeep, you understand, right? How we come? No? Yes or no? I can't hear you. Hello?
So, sir, I understood, sir.
Okay. Let's move. Okay. Yeah. So find maxima and minima maybe for this. Easy, but just for your you understand, you know, right, how to find maxima and minima.
Yes, sir.
Okay, tell me the answer. Okay, otherwise I'll do after that. So if someone forgot, so g x prime x has to be equal to 0, and with that, if you have g double prime x naught is strictly greater than 0, then it is, I think, maxima, right? No, sorry, minima, right? Minima. And g double prime x star is less than 0, then maxima, right? Correct.
Yes, sir.
Yeah, so now we find out.
Done, sir.
Sorry,
Done.
what are the answer? Like maxima?
Maximum is 7. Minimum is minus 9.
Okay, so that hopefully it is correct. Good. So, Sandeep, you do, then we will move. Hmm?
Yes, sir. Same answer.
Same answer. Okay. So g dash x is equal to 8 minus, because see, this will be seen by many other people. So that's why I just wanted to do this. right? So 8 minus 4x cube. So if x cube equal to 0, so x cube will be 2, right? At x cube equal to 2, it will be the maximum or minimum which is there. So g double prime x, if you do, that will be, hey, did I do any mistake here? No, right? Yeah. So g double prime x will be minus 12 x square. What I even mistake here?
Sir, there is no mistake.
Sorry?
There is no mistake.
Yeah, yeah. So g double prime x is always less than 0. It is coming like that. So that's going to be. How did you find that?
Sir, g dash x is always greater than 0 in the interval.
G dash x.
Yes.
Then.
When the function is increasing.
No, that is g dash x is even if it is okay, okay. It's a maximum minimum. Okay, it's not even critical point. Is not we don't need here. Okay, okay, okay. Understand. So this 8 minus 4x cube. Okay, okay, okay. Understand. So x is between 1 to minus 1, right? Okay, okay. This question setup was wrong from my side. Anyway, x cube will be from 1 to minus 1, right? And you have minus 4. So minus 4x cube will be greater than equal to minus 4 less than equal to 4, and you use add 8, so it will be 4 less than equal to 8 minus 4x cube less than equal to 12. So 8 minus 4x cube is always greater than 0. So strictly greater than 0 even. So that's why you have g is monotonically increasing function. So yeah, that's why this g at minus 1 will be the minimum, and that is minus 8 minus 1, that is 9, minus 9, and g of at 1 it will be maximum, that is 7. Okay, so that this is the not the one I wanted to tell you. So this critical point, maximum minimum I wanted to find. Okay, anyway, so that leave it. This that becomes very easy because of this increasing thing. Okay, answer is also this, so it's okay. We'll move to the next question. Yeah, this is interesting. This you can use the this maxima minima, this squeezing critical point that for this question. Right.
Done, sir.
Okay, I'll wait for Sandeep, then we'll do it again.
Yes.
Sir, I do not have any idea how to do it.
Sorry?
Sir, I am unable to do it.
You are unable to do it.
Yes, sir.
Okay, then I'll do 1 minute just. Okay, so tell Advait how you did it.
We can take a rectangle with length A and breadth B,
We will take rectangle with length A and breadth B. Okay.
and area capital A.
Area capital A. Okay.
So the perimeter will be 2A plus 2B,
Perimeter will be 2A plus 2B. Correct.
and capital A is equal to AB.
Capital A is equal to AB. True.
So we can find small b in terms of capital A and small a.
Yes. That is 2 times A plus A over capital small A. Right. That is the perimeter.
Yes.
Let's say
So we
S.
have to maximize this.
Exactly, you have to maximize this one. This is the function which is depends on A. Let's say perimeter which depends on A, and you have to maximize. You given the A is given, so you don't need to worry about A capital A. That is we given area, and square.
Minimize this, sorry.
You have the smallest perimeter means you have to minimize this. Yes. So the what to do that? This is a ds dA is 2 times 1 minus A over S square, right? And yeah, so that is equal to ds dA is equal to 0, imply A will be plus minus square root A. Correct? Now d2s dA2 will be minus of 2 times, okay, A to the power minus 2, so it will be 4 times A over, and it will be plus AQ, right? 2,
Yes, sir.
right, so minus 2 to the power minus 3. Yes, correct. So which is d2s dA2, and is greater than 0 if A is equal to square root A. So A cannot be negative because A is the, I mean, length, right? So it can be negative also. So A is equal to square root of A. This is positive. Hmm? So it has minima when A is equal to square root of A, and then B will be A over square root of A, because small a is square root of A, that is equal to square root of A. So A is equal to B. When A is equal to B, perimeter is smallest, right? And what is the meaning of A is equal to B for the rectangles? They are nothing but the square. They are square because A is equal to B, right? It is very easy, but you see it gives a very strong result. The calculation was easy, and it is using this critical point and all, a small as thing, but it gives the result that among all the rectangles of a given area, the square has the smallest perimeter, right? The result is strong, but the way we do it is, I mean, the way using it is very, it becomes very easy. It's correct. So, you have any doubt here? Hopefully not.
No, sir.
Okay. So then we'll do the last question for today. So this time I don't have much question maybe. So this will, after this we'll just Stop. If you have any other question, you can tell. Otherwise, we will stop with this one. I know this is easy, but you do it. Maybe I'll try to find one more question, then we'll just.
Done.
Okay. Oh, 1 minute. The domain also you should specify, whether which domain you are taking.
Yes.
What's the domain?
-1 to infinity open.
Minus infinity to.
-1 to infinity.
Okay, that type of things will be coming. So it's not just infinity to infinity. One more question I'm looking for you, so that it will be good. Few questions were there I kept in mind. I forgot just now that what are the questions. Some interesting questions were there. Forgot to bring that. Let me just give some time. I'll just maybe 1 2 minutes. I'll just check. Yes,
Sir, I am unable to find the inverse of the function.
I'll show you. I'll show you. I'm just searching for the
I
next.
am giving some ln 1 plus uh, gx gy.
See, gy is e to the power y minus 1. So to find fx such that fx is inverse of g means you have, okay, so fx gy, if you take gy is equal to x, then what happens? Solve it. You'll
Sir,
understand.
y is equal to ln 1 plus x.
Yes, y is equal to, so e to the power y is equal to 1 plus x. So then y is equal to ln of 1 plus x. So fx is equal to ln of 1 plus x. That is the inverse, and that has to satisfy that has to that will be defined only when x is strictly greater than -1. That's all. What you thought? So that's the answer.
Yes, sir. I got the same, but I was confused. We should again put the value of x there.
No, not like that. Okay. Let me find it. question. I'll give you just now question one. Depends on defensibility, right? Okay. I found the question. Now I'll just put it. Yeah, so this question, can you do it? So f from -1 to 1 to r such that f0 is equal to 0. No, sorry, not f0 is equal to 0. F of 1 by n is equal to 0 for all n. Show that f dash 0 is equal to f double dash 0 is equal to 0. Yeah, and f is twice differentiable. F is twice differentiable. All this, f is twice differentiable, and f of 1 over n is equal to 0 for all n. Can you show that f dash 0 is equal to 0? Also f double dash 0 is equal to 0. This is a good question. Don't search in internet and all, huh? Try to do by yourself. Any idea here?
Sir, I think we need to use a sequential criteria. Yeah.
Okay. Then
Then we can use the given conditions f of 1 by n is equal to e.
no, you have to find here f dash 0. What is f dash 0? f of h minus f of 0 over h, that limit h tends to 0. Hmm? So,
Since f is twice differentiable, so first derivative will exist.
so are you agree with this first of all? Yeah, those are okay. But h tends to 0, f of 0 is equal to 0, right?
Yes.
Right? Because 1 by n, f converts to 0.
Yes,
So
sir, it is continuous.
f of 1 by n should also converge to f of 0. But what is f of 1 by n? Because f is continuous, because it is differentiable is continuous. So f of 1 by n is 0. So 0 sequence only can converge to 0. So that is f of 0 is equal to 0. So that's why we get f of h over h. That
Now, sir, here we can use the sequential criteria.
yes, that's what we will use. But how? What to use that so that it will be 0? Hmm?
Sir, since sir, it is twice differentiable, so first derivative will exist. So when we tend to zero using any sequence,
Yes.
it must exist, and
Yeah,
and
exist. But what is the problem?
that will be the derivative, sir.
What will be derivative?
So zero.
No.
If you take the sequence, sir, 1 by n,
Hmm. Yes.
so it is given that f is 0 at 1 by n, sir, for all n.
Yes.
So this limit will be, sir, 0, f of h by h.
No, no. H
Why,
equal to
sir?
sorry, H equal to 1 by n.
Hmm.
Yes.
Sir, we want to find this limit when h tends to 0.
Yes. H equal to 1 by n when and f of h will be 1 by n. Right?
Uh, there it is given that this is 0.
F of 1 by n is 0. Yeah, that also is okay, right? That you can do. Yes. H tends to 0. Instead of that, you take
Limit n
n,
tends to infinity.
n tends to infinity f of
F of
1
1 by n,
over n, right? Sorry, over 1 by n.
1 by n. It is 0.
But 1 by n is or f of 1 by n is already 0. So I think yeah, that is correct.
Yes, sir.
And if you want to do f double dash 0, then what we will do? So you have to do you use the similar kind of idea. Okay, limit n tends to infinity. Mainly you have to use find the sequence f of xn minus f dash 0. Sorry, f dash 0. So f dash 0 is 0, right? That is also 0. F dash 0 is 0. So x naught minus 0 you have to find sequence. Where n tends to infinity, as n tends to infinity, xn tends to actually 0. Hmm? So for that, so what we will get n tends to infinity f dash xn over xn, this sequence. So, but this becomes little difficult. So people usually try to find using mean value theorem. Hmm? Mean value theorem, you will find always a sequence between 1 over n plus 1 to 1 over n such that f dash xn will be f of 1 over n plus 1 minus f of 1 over n over 1 by n plus 1
Sir,
minus 1 by n. Hmm?
sir,
Yes.
sir,
Which
we know that this is twice differentiable, sir.
yes, yes.
So the limit n tends to infinity, f dash xn by xn also exists.
Exist, yeah, that I we know. Then
So can't we distribute it in numerator and denominator because both both limit exist,
no,
right?
no. You would know fn over gn that converts to something that does not imply fn also converts, gn also converts some
But
just thing.
but we know, sir, na here because f dash xn converges to 0 by previous argument and xn
That is
also
true.
converges.
That is true. Also, xn converts to zeros.
Yes, sir.
What
So
you
we
do?
can distribute it, sir.
Distribute what? Where? No, not
Like
possible.
we can write, sir, limit n tends to infinity f dash xn upon limit n tends to infinity xn.
Yeah, you do that. Then what will happen?
So the above limit is 0.
No, no, no. You cannot say. Hey, yeah, below limit also zero. Then what do you do? Because n tends to infinity, xn is converging to 0, right?
So we do not, if we not use simultaneously, the upper limit is zero, numerator limit is zero, so
No, no,
that
no, no, no. 0 by 0, you cannot do that because 0 by 0, right? It can be in infinity, it can be 0 also, okay? You can use some different way. So let's say 1 by n and 1 by n square, both are converging to 0, but this will converge to infinity. Hmm? This
but
thing.
the
So,
limit exists, sir, it is given.
yeah, but still you cannot say from here, like you have to use different logic maybe for that. Huh?
But why we are
That
getting
theorem says the denominator should not be zero.
Denominator is converging to 0, right?
hmm.
Yeah, so that's why you cannot use this logic, the zero limit extends to infinity f dash xn. You are whether it is going faster or not, that you don't know. Hmm? Even 1 by n square which converts into 0 and 1 by n which converts into 2, so then that case both converts to 0. But sometimes when 1 by n over 1 by n square, that converts to infinity. So it depends how much faster it is going, but you don't know about f dash xn and xn how much faster it is going. So that's why you have to construct a sequence xn belongs to this such that f dash xn is equal to 0. And when you have that, then you can show that for a sequence which is xn which belongs to 1 by n plus 1 to 1 by n means it always converts to 0. But for that you have f dash xn is equal to 0. But xn's are not equal to 0. So for that case you will get f of f dash xn over xn that is converging to 0. Limit as n tends to infinity. So what you will have mainly, and that's what you had here, f dash xn over xn, this one, right? So you can say that double dash 0 has to be equal to 0 because it exists. So for a sequence, you will see that is equal to 0, so it has to be equal to 0. Correct? Yes. Okay, so
Sir,
let
if we
yeah.
if we change the domain, then can be there some problems, sir.
Which domain?
So minus one to one. F is defined from one minus one to one.
Not really. I think 0 to 1 also will be okay, no problem. But yeah, one way you get, yeah, 1 by n, 1 by n plus 1. Yeah, I think no, don't will be a problem. But the idea is like this.
Sir, if we can define F from R to R, then also this result is true. In that case,
Hopefully so. Yes. Yes.
okay.